The Eocene epoch, spanning approximately 56 to 34 million years ago, was characterized by climatonic conditions, specifically a warm global climate that enabled tropical fauna, including early primates, to expand their geographic range. This epoch represents a fundamentally critical period in primate evolution and primarily defined by a massive adaptive radiation of early primate forms. The Adapoids represent one of the two major superfamilies of strepsirrhine-like primates that dominated the Eocene fossil record, the other being the Omomyoid. So let's really dive into what this world was like. We're talking about a planet that was way different from ours today. Just imagine these massive, lush tropical forests stretching pretty much across the entire globe, even in places like North America and Asia. This incredibly warm and stable climate was, well, it was the perfect stage for evolution to really kick into high gear. And out of this explosion of life, two major groups of primates emerged, and they really set the foundation for all the primate lineages that came after. These were the Adapoids and the Omomyoids. All right, first up, let's get to know the Adapoids. Now, these guys are really important because they're the ancestors of some primates that you might find pretty familiar today. So let's take a closer look. So what were these Adapoids all about? Well, for one, they were generally diurnal. That just means they were active during the daytime, out there foraging for food and socializing while the sun was up. And this is actually a huge deal evolutionarily speaking. By being active in the day, they were able to tap into totally different food sources, and they didn't have to compete with all the other mammals who were still mostly nocturnal. They basically carved out a whole new niche for themselves. And if you're trying to picture them, the best modern-day comparison we have is a lemur. And that lemur connection, that's where their evolutionary importance really shines. Adapoids are widely believed to be the ancestors of all modern strepsirrhine primates. That's the group that includes the incredibly diverse lemurs you see in Madagascar, and also the lorisids, animals like bush babies and lorises that are found all over Africa and Asia. So the key takeaway here is pretty amazing. When you look at a lemur today, you're basically seeing a living, breathing echo of these ancient Adapoids from the Eocene forests. Okay, so now let's switch gears and talk about our second major group, the Omomyoids. While the Adapoids were out there taking over the day, a completely different kind of primate was making a living in those exact same forests, but under the cover of darkness. The Omomyoids were pretty much the polar opposite of the Adapoids. They were the nocturnal specialists. These were generally smaller animals that really thrived in a world of shadows and moonlight. And, that kind of lifestyle, it demands a completely different set of skills. They had these specialized adaptations, especially for their senses, like huge eyes to see in the dark and incredibly sensitive ears to track insects and other little critters at night. So where do these little guys fit into the grand primate family tree? Well, Omomyoids are the top candidates for being the ancestors of modern tarsiers, those small primates with the enormous eyes from Southeast Asia. But science is never quite that simple, is it? There's another really interesting idea based on some early tarsier fossils that suggests Omomyoids and tarsiers might actually be sister lineages. This would mean they evolved side by side from a common ancestor. It's a really fascinating puzzle that paleontologists are still trying to piece together. So we've met both families now, the daywalkers and the night dwellers. Now let's put them right next to each other to really get a clear picture of the key differences between these two fundamental primate groups. This table just lays it all out perfectly. On one side, you have the Adapoids, bigger, active during the day, lemur-like, and the ancestors of modern strepsirrhines. Then on the other side, you've got the Omomyoids, smaller, active at night, tarsier-like, and leading to modern tarsiers. They really represent two completely different but highly successful strategies for being a primate back in the Eocene. It's like they split the 24-hour clock right down the middle between them. But that warm, jungle-filled world of the Eocene, it just couldn't last forever. As we get closer to the end of that epoch, the entire planet's climate started to shift in a pretty dramatic way. And this change, well, it was going to have huge consequences for all those primates that had spread so successfully across the northern continents. Like all other early primates that dispersed into high northern latitudes during the Eocene, the Omomyoids were ultimately driven to extinction. The subsequent cooling of the global climate led to the extinction of these early northern primates. The primate lineages that survived and contributed to the subsequent Oligocene radiation, including the first anthropoids, did so primarily in Africa and Asia. We will talk about them.